statistics. For those who don't know what statistics is, it's really just how people organize number. There's a lot of data out there. How is it that we can make sense of this data? And so the two ways we're going to look at today is descriptive statistics and also inferential statistics. Basically, descriptive statistics describes the data. That's why the word descriptive is in there. It describes what the data looks like. And inferential statistics is what we can infer from the data. That is, given the results, can you apply this to a larger generation, a larger population? Okay, let's start with descriptive statistics. And there's the first thing that we have to do is kind of measure the central tendency. What is the average, basically, of this data set? And there's three ways that we're going to look at: the mode, the mean, and the median. So let's talk about each of them first. The mode is very simple. The mode is the most popular answer. So the one that is of the data set, popular. In the data set, the number that comes up the most is the mode. So for example, if I'm interested in the central tendency of, say, this class's test score, how well did you do in this test? One way is to give you the average of it. And which average I'm going to choose? The mode is the most popular. If more people got 82 than any other score, that is the mode. That's the most popular one. Now the mean is the mathematical mean, which is the average. And this is probably the most common way people study averages, which is you take the sum of all the scores and divide it by the number of instances there are. So if you use the same kind of class and test situation, I might add up all the class's score and divide that by the number of students there in the class. So if I add up all the scores and it's 95, and there's 10 students in the class, I divide it by 10, and the answer will give you the average is 9.5. The median is a little trickier. The median is the number that divides the class in half. And basically, to get that number, you line up all the numbers numerically from lowest to highest, and then pick exactly the middle number that occurs in the data set. So half of the class did less than this number, and half the class did more than this number. And it's basically as easy as lining up all the answers. Suppose you got like a 1, 2, 5, 6, 10, 11. And to pick the middle number, in this case the middle is between 5 and 6, so that number would be 5.5. That's the median. If you had an odd number of letters, it's exactly the one in the middle, which is 1, 2, 3, 4, 5, 6, 7. So the one in this position, 6 would be the median number. So there's different ways to measure the central tendency of a group of data, and these are the three ones that you'll be tested on in AP Psych. To describe your own data, the idea of percentile comes up a lot. For those who've taken like SATs or AP Ready, they do give you a percentile. Basically, if they give you a percent, that means you did better than that many percent of the people who did it. Let's say, for example, you take the psych test and you got an 84 percentile. That means you did better than 84% of the people who took the same test. Incidentally, it also means that you did like you did worse than 16% of the people. And that's how it's scored. So for example, if I give you a question like, how tall are you? And you tell me that you're in the 75th percentile, that means that you're taller than 75% of the people you're compared to yourself to. Okay. There's an item here on skewed distribution. We'll see an example of that later on. Oops. Okay. Let's look at this graph of how they organized frequencies of items. Suppose this is the test score. And for each of these bars would be a score. For example, this would be like 10, 20, 30, so on and so forth, all the way to 100. A histogram basically adds up the number of instances of that data point. So you take how many people scored 10 on this test, and you just mark this as 2. Here's the line, and this is the frequency of it. And this might be 1, and this might be 2, so on and so forth. You've probably seen this graph in other math classes before. And this is one way to summarize the data. And you can see one thing that happens in large groups of data is that there's usually a central mean. In this case, it's right here. What is it? 40, 50, 60 points. And there's not a lot of people who do better, not a lot of people who do worse. And from that, we could draw a normal distribution curve. Basically, this is in a normal distribution curve. It means, on average, this is how people score on that. They score around the mean, and it's kind of symmetrical on both ends. Let's look at the next graph. groups. And here's an example of this normal distribution. There's two tails. It goes up in the middle, a lot up in the middle, and then goes back down again. And in this case, in the normal distribution curve, the midpoint is exactly here, and it's also the average, mean, and also the median and mode. So all three, in this case, converge at one point, which is here, in the normal distribution. Now you might get skewed distributions, which is a lot of people do skew towards one end. That means a lot of them do like one way or the other. The first one is positively skewed, and that means more people scored in the low end of the curve. So if this is a really hard exam and people did really poorly, you get a kind of a positively skewed distribution. On the other hand, if it's a very easy test, more people kind of gravitate to this end, the higher end, and that's a negatively skewed distribution. You can see that the naming is tricky. But one way I would advise you remember this is that if the tail is pointing to the positive side, it's a positively skewed distribution. If the tail is pointing at the negative side towards 0, that's a negative distribution. That's like a quick and easy way to memorize these distributions. You could also get bimodal distributions. This is an example here, where there's the scores kind of split. So for example, some people either, if this were a test exam, some people did really poorly on this, scored very high, and a lot of people did really well on it. Not a lot of people did in the middle, so they kind of split that way. And that's a bimodal distribution. You can have even more than two modes, like multimodal distributions. That'd be crazy.